Howdy Chemsters, it's Bowles. I'm going to give you a few notes on flame tests so that you can understand what this lab you're about to do is about. So as you can see from this description on this slide, a flame test is a test used in the lab to look for the presence of certain metal atoms. So remember, metals are on the left of the periodic table, and so we're testing for certain metal atoms. And the sample basically of a compound, remember this is a compound, so it has a positive atom and a negative atom in it, or atoms, and it's going to form a compound or a salt, and these are going to be tested in the flame. And they bring characteristic colors. So here's what you need to know about that. We talked about electrons and electron configuration notation, and basically what happens is that atoms in which all of their electrons are in the lowest possible energy levels, that means as close to the nucleus as possible, beginning with the 1s and working their way out, they are in their ground state. But when atoms are heated or zapped with energy, electricity, they can absorb energy. If they absorb enough energy to jump to another level, remember that energy is in packets, so jumping from one energy level to the next requires a certain amount of energy absorption. If that happens, then the atom is said to be in its excited state. So an excited state means that an electron, at least one electron, has jumped out one level or more, depending on how much energy it absorbs. Now, when that electron jumps out and then falls back into the ground state, it can release a packet of light called a photon. And when, as I mentioned earlier, when the atom's electron jumps out, this is known as an excited state. When they're all down at their lowest possible levels, that is the ground state. And basically when they fall back, they can release light in the form of a photon. Now, depending on the wavelength this light has, it will give a characteristic color for that atom in particular. So when you look at the electromagnetic spectrum, which is things that travel as waves through space, you notice that it is based upon wavelengths here. So these are the wavelengths. The wavelengths, longer wavelengths are items like radio waves, microwaves. Shorter wavelengths are things like gamma rays. We learned about those, which are released during nuclear changes or nuclear fusion or fission. But the section of light that we can see is called visible light. You've heard of the color spectrum or the colors of the rainbow, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. Those are visible light. So if the energy that comes from these atoms, in the case of the flame test, that photon of light happens to be in a wavelength that we can see, and it will come as a color, a specific color. So think about light, for instance. White light is actually made up of many, many different colors of light, and if you were to split that light with a glass prism, it would show the colors in the rainbow. You've heard about this in your previous science classes, or maybe even when you were younger. So what you need to know about flame tests is they can be used to identify certain elements, certain metals, because it's like a fingerprint for the atom. That photon, that energy packet that is emitted, has a wavelength, and if you're able to split that light, for instance, like with the prism, if you're able to take that light that was emitted from the atoms and split it into all of its various colors, you would end up with what's called a light emission spectrum for that atom, a light emission spectrum. And so, for example, this first one, this first light emission spectrum is for hydrogen, the element hydrogen, and the one below it is for the element iron. So you can see that two very different substances have their own emission spectrum, and you can use that to identify this element, like a fingerprint for a person. So here's a few more light emission spectrums. So the first one here represents the sun, and in order to determine what elements are glowing or showing their light by the sun, you can compare the various parts of it and see that hydrogen has this emission spectrum, and helium has this emission spectrum. This one is mercury, and this one is uranium. So if you want to kind of see what combinations the sun has, you can look at what elements and what colors are present. But notice each specific substance tested has a very specific emission spectrum. So they can be identified that way. And so that's how we know the sun is primarily composed of helium and hydrogen. So in the lab that you're about to do, what you're going to do is you're going to take these different substances and you're going to put them in the flame and determine what colors they have. Now we can't go back and split those into a very specific emission spectrum because we have to have a machine that's able to do that, basically take the light that comes from that and separate it. We're just going to see with our eye the light, and with our eye we're going to determine the flame color, and then I'm going to give you an unknown. You're either going to have X, Y, or Z, so make sure you mark that when you do the flame test lab, and then you're going to determine your unknown because it will be a metal from one of your knowns. And just so you know, the metals are here: sodium, potassium, copper, sodium, strontium, copper, sodium, potassium, and strontium. The second part of the formula is those are all non-metals and what we call polyatomic ions. So primarily what you're testing is the front element in a flame test. I wish you good luck, guys.